Okay, now let's talk about how exactly we can take a circuit with some information that we know, and we can analyze that circuit so that we can find out the voltage, the current, and the resistance of each of the components that make that circuit up. Now, before we get started, there are going to be two things here that you want to have on hand. Number one, a calculator or access to a calculator app just on your cell phone. And also, you're going to want to have your circuit rules handy. And these are available to you on your OneNote, or you can take a screenshot. You can make an index card for yourself. You maybe wrote them in your notes. However you do it, always having these in front of you when you're working on circuits is a huge help. Now let's remember the basic series circuit rules. First of all, our total voltage is going to be the sum of all the voltages of the resistor components, okay? And so then our current is going to be the same everywhere in the circuit. And then our equivalent resistance, you can kind of think of this as the total resistance. That's going to be a summation too. That's going to be the first resistor plus the second resistor plus the third as we go around the circuit. So I'm just going to put these to the side so I can see them and help myself if I need them. And then let's come back here. And the first thing, let's fill in some blanks. First of all, my total voltage is going to be equal to that voltage at the power source. So my total voltage here is going to be 10 volts. And then my resistance for resistor 1, it tells me is 20 ohms. So I'm going to put that in. Second, and I think there's a typo here, that's okay, that is going to be 19 ohms, resistor 23. And then the fourth resistor, which is really the third resistor, is going to be 20 ohms. All right, so where do we begin? First of all, let's remember Ohm's law. That's that master kind of simple law that governs the relationship between the power supply, the push of the current, and the resistance and the voltage. Okay, so we have Ohm's law equals V equals IR. Now, what we want to know is we want to know V, I, and R for every single component in this circuit. And right now, I only know one of the three for all of these. And so it becomes a little bit of a puzzle game. So if I look at this, do I have any way right now of getting the current I for any of these right now? No, I don't. Do I have any way of getting the voltage at either of these resistors? I don't have the ability to do that unless I know the current. So I can't get V anywhere. Well, how about R? Well, I already know R here, R here, R here. Can I get R here? This would be Req, or the total resistance. Well, wait a second. If I use my circuit rules, yeah, I can actually get that. Because remember that in a series circuit, the equivalent resistance is equal to R1 plus R2 plus R3. Or in our case, sorry, because of our goofy numbers, R2, 3, and R4. And all I need to do is just plug those numbers in. So I have 20 ohms plus 19 ohms plus 20 ohms. And so my total resistance here is going to be 59 ohms. And I can come down and put that in here. 59 ohms. And I can write it up here. Okay, well, hey, good news, folks. Guess what? We now have V and R here. So what can I find? I can get the current here. And if I know the current here, my series circuit rules say I know the current everywhere. So let's do that real fast. I can rewrite Ohm's law to solve for I. All I need to do is divide both sides by R to get I by itself, and I get I is equal to V over R. So let me come down here. My I is going to be equal to my total voltage over my equivalent resistance. That is going to be equal to 10 volts divided by 59 ohms. And when I get my calculator up and going, I just take my 10, divided by, yeah, you guys don't need to see my messages. 10 divided by, what was it, 59, equals, what does it equal? It equals 0.17. So I'm going to get 0.17 amps. Okay, fantastic, because guess what, guys? If I know the current here, I know my current everywhere. So this is 0.17 amps, this is 0.17 amps, this is 0.17 amps, and this is 0.17 amps. And now guess what? For resistor number 1 here, I have R and I can solve for V. All I have to do is solve V equals IR, Ohm's law, for V, and that equals IR. So I'm going to take that times that. So V1 equals 20 ohms times 0.17 amps. I do my math real fast. 20 times 0.17, and I get 3.4 amps there. I take the 19 for V23, that's going to be 19 ohms times 0.17 amps. And sorry, that was 3.4, and that's volts, not amps. I'm trying to go fast here because I'm afraid my camera's going to freeze up. Okay, and oh good. So 19 times 0.17 is 3.2 volts. And for my third resistor, which is V4, I'm back to the same thing here. I have 20 ohms times 0.17 amps. I'm going to equal 3.4 volts. Now, and this is a V, it's not a very good V. Okay, so here I have 3.4 volts again. If I take these, remember, because my circuit rules say that all 3 of these voltages have to add up to 10, do they? Yeah, they do, and that makes me happy. Okay, and it says that all of the resistances have to add up to the total or equivalent resistance. Do they? Yes. And it says that my current should be the same across the circuit. This circuit is solved.